we want to differentiate, I immediately notice that the base of the log is not natural. It's not e, in other words, it's 5. So when I determine f prime, I will have to write 1 over x e to the x. I cannot forget to write natural log 5, but now I have to multiply by the inner function prime. Can anyone help? Please. I always say please even if I forget to say it. So it's please.
E to x.
This is a product. We have to we use the product rule.
E to the x.
Yes. Parentheses, e to the x plus
X times e to the x.
That's it. And we notice that we can simplify a little bit. What am I thinking of? Can anyone help?
Factoring e to the x in the numerator.
Right. So which page am I on now? 9. Yes, e to the x in the numerator. And what is left in the numerator?
1 plus x.
Very good. I simplify, and the final simplified form, x plus 1 over x natural log 5. Any questions? Any questions? Okay, the next topic is extremely important. It's called logarithmic differentiation. I'm sorry, forgive me. Do you have any questions for me? Anything? Anyone, please? Okay, so we listed a lot of rules here. I didn't list the power rule and the chain rule, but we know them already. In certain situations, like for example, one specific one, there are others, and we can talk about those. When I have a function raised to a function, here's an example. Let's say 2x plus 3 raised to power sine x. Another example, tangent x raised to power natural log x. And I can continue forever. Sine x raised to cosine x. And so on and so forth. We have no differentiation rule. There is none. Don't try to say bring g down, subtract 1 from no. There is no such rule. Our only hope is this. So in a situation in which a function raised to another function do not confuse this with natural log x to the third power. That's not a function raised to a function. That's just a function to the third power. And if I want to differentiate, I will bring 3 down by the chain rule, subtract 1 from the power, and differentiate the inner function, which is 1 over x. This is not what I'm talking about. I'm talking about a function raised to another function, not a number, not a power. Sine x raised to cosine x. Please choose any of these or make one up so I can illustrate logarithmic differentiation. Make one up. Anything you want. A function raised to another function. So we can illustrate how logarithmic differentiation works. Anyone? Or you can choose one of these or just make one up. Anyone?
How about cosine of x raised to sine of x plus 1.
Great job. Our first step must be to apply. So we are asked to find f prime of x. That's our question. As the first step, we have to apply natural log to both sides. For simplicity, I will replace f by y first. Because it's easier, I cannot really say, although I can, but it's easier to say natural log y versus natural log of f of x. So we're going to apply natural log to both sides. Good. So next step, the left-hand side is natural log y. And the right-hand side is natural log of cosine x raised to sine x plus 1. Anyone remembers a property? And I haven't heard from I think I heard from everyone, but let's say Carson. Do we know any property of the natural log or any log that I could apply now?
I'm not sure.
Anyone else? Does anyone remember a property of
Can't you bring the exponent in the argument down in front of the natural log?
Yes. Thank you. It comes in as a factor. Please do not put plus or minus or forget that it's a factor. It becomes a factor. Good. So then we have natural log y equals, I have to write parentheses, sine x plus 1 and multiply by natural log of cosine x. At this point, this is step 2. Differentiate. Of course, implicitly. To find, of course, dy over dx. Can anyone get us started, please? Give it a shot, even if it's not 100%, because by talking, you learn from your mistakes.
Is it 1 over y dy dx on the left side?
Very good. Perfect. Completely agree. Yes. Next.
Would we use the product rule for the
Absolutely. Thank you. Absolutely. Yes. Of course. Good. I'm ready. Function 1, function 2.
Function 1 would be cosine x
Times function 2 plus function 1 times function 2 prime. I'm ready when you are.
Would it be 1 over cosine x times dy dx?
Times, there's y is only here. We don't have any other y's anywhere. Times the inner function prime.
Cosine x? Or sine x?
With minus. Very good. Good. Perfect. So remember, this is what we are after. So what should I do to both sides to simply get dy over dx on the left? I don't want to see anything else.
Multiply both sides by y.
Exactly. But I'm not going to copy y. Why? Because I'm lazy. I'm going to copy directly the function. Cosine raised to sine x plus 1. Cosine x raised to sine x plus 1. I'm going to open a bracket and write all this as much as I can, simplify it. So cosine x, natural log of cosine x. Obviously, there is a minus here. Sine of a cosine. How much is sine of a cosine? There is a function that is exactly sine of a cosine.
Tangent.
Perfect. So times tangent x, and this is done. It's our only possibility to determine dy over dx, because there is no differentiation rule for a function raised to another function. There is no such thing. We cannot bring g down. Don't try. This is allowed. Yes, I bring 3 down, I subtract 1 from the power, and I differentiate the inner function. But here that doesn't work. In these situations, I have to apply natural log to the original equation and then differentiate implicitly. Would you like to choose another problem?
I have a question real quick.
Please,
Professor.
please, please.
So you see how we put the cosine x raised to the sine x plus 1 in the very beginning? Do we always do that for every logarithmic differentiation, or this is just for this one?
You have to multiply both sides by y, because if you don't multiply by y, you haven't solved for dy over dx. You have to multiply by y.
Oh, and y was the function?
Yes.
Okay, I got it now.
So that's why, since you have to multiply by y, I'm not going to write y here. Who knows what y is? We have to write the function.
Okay, thank you.
Thank you. Other questions?
Yeah, so could we have solved this problem also using the chain rule, right? Or no?
Never. The chain rule, it does not work for a function raised to a function. This is the only way. For a function raised to a function, only to apply log to both sides and then apply logarithmic and apply implicit differentiation. There is no other way. We apply the chain rule. For example, here we applied the chain rule. Yeah, but I cannot apply the chain rule for a function raised to another function. Do we need another example, or can we continue?
Should we do one more example, please?
Sure. Would you like to choose? Anyone would like to choose from either the book or anywhere else, or you can make one up? Anyone would like to make one up? Or give us any example, any problem?
I'm interested in what if it had, like, it was raised to an exponent and then raised again.
Yeah, whatever you have. Just give me an example.
How about tan of x raised to the x plus 1 and then raised to 7.
Like this?
Yes.
Perfect. So first that's our first step. We have tangent x raised to x plus 1 to the 7th power. We apply natural log to both sides. And the next step would be natural log y. We have to bring the power in front, so it's x plus 1 to the 7th times natural log of tangent x. And now who would like to help with implicit differentiation? Anyone?
It would be 1y over dx dy, correct?
Very good.
Or,
Awesome.
sorry, times dx dy.
Yep, perfect. Now remember, this is function 1 and this is function 2. Ready?
Start with 7x plus 1.
7.
X plus 1 to the 6th power
Very good.
times 1.
Times
And
natural log
plus
tangent x. Yes, times the inner function prime, which is 1. Yes, thank you very much. Yep. Plus x plus 1 to the 7th times
1 over 10x times secant squared x.
Excellent. Great job. So of course I have to multiply by y, so this is dy over dx. And y is, I copy it from the very beginning, tangent x raised to x plus 1 raised to the 7th power. I could factor out x plus 1 to the 6th. Let's leave it alone. So x plus 1 to the 6th natural log of tangent x, and plus x plus 1 to the 7th secant squared over tangent x. And yes, this is the only way